So I want to take a minute to talk about discrepancies between different devices, different pieces of equipment, whether it be voltmeters, amplifiers, testing equipment in general. Um, we have all sorts of ways to test the power out of amplifiers. And this is why I want to talk about this before I post some a couple of my next videos or one of my next videos, because there was a discrepancy between the base head garage watt meter and the term lab in the lanes at the show, and it was about a 10% discrepancy in between the term lab and the base head garage watt meter, and they are different pieces of equipment, and the term lab is definitely much more sophisticated. So the term lab it clamped roughly 1975 watts out of my amplifier, out of one of my amplifiers, and the base head garage watt meter clamped roughly 2225 watts, which is about 250 watts differential in between the two readings. So that's about a 10, just about 10%. So there's a couple things going on there, and one of them I will not be able to tell you because that's not my term lab. I don't have a term lab anymore. But the person I sold my term lab to, I'm sure he's going to let me do some testing. I just have to find the time, between my schedule and his schedule, and sit down and do some testing because there's so many settings on the term lab that it's hard to tell how the term lab was set up at the show. But like I said many times, as long as everybody is being clamped the same power at or clamped the same way at the shows, then it's all fair. So that really don't matter when you're at a show. Um, if if the same term lab is used on every single vehicle that's being clamped, then it should be fair play. Should be. So that being said, like I said, there's a lot of different settings on the term lab. You can clamp power based on max SBL. You can clamp power based on just absolute max power in general. And there's some other factors involved as well. But here's something to take into consideration. Take out the settings of any device, whether it be the AD1, the amp dyno, or the AMM1, the portable handheld amp dyno. They're made by the same people, and they don't register the same numbers. If there's a video out there, can't remember exactly who posted it, but I can find it. It's on YouTube, and they have on the same test, and it was on a resistive load on a set of resistors. It was the amp dyno. It was the AMM1, the little handheld amp dyno made by Steve Mead and Tony DeMore, and it was also the base head garage watt meter, and they all three produced different numbers, and they were relatively off. Not by a huge margin, but they were off. So looking at that video and those results, that got me to thinking, several years back, I taught myself to work on amplifiers, to repair amplifiers. I've repaired about 40, 45 amps, several years ago out of necessity. No, I don't fix amplifiers anymore. But I do have this one. I'm going to recap this amplifier. This is a Phoenix Gold M50. Got it on Marketplace. And I still have to replace the input filter caps. And, there's something wrong with it, but that's not why I'm here. Reason I have, since I have this amp on this bench here, every component here has a value, whether it be a capacitor, a transistor, a MOSFET, a transformer, whatever it is, PWM, whatever it is, it's got a value, and each component has a tolerance. And most good equipment will have components inside that are have a tolerance within 5%. 5%. So, with that being, and that's good equipment. Now you have tighter tolerances on really, really precise equipment, which is not going to be in the car audio realm, because just be honest, it's not rocket science, it's car audio. They're not, if we were in the precision components, the prices would skyrocket, because the prices of each component is going to be astronomical compared to what they are. So you have precision components that are a tolerance within like 0.5%, 1%, probably even 0.1%. But most good equipment has a tolerance of within 5%. Crappy equipment will have a tolerance between 10% and 20% on certain components, especially like capacitors. So what does that mean? So let's just move this back. So what does that mean? All right, when we're talking about clamping power and using a clamp and a voltmeter versus a base head garage wattmeter type of deal, or an amp dyno, or the AMM1, the handheld dyno. When you're talking about using different device, or the SPL labs, I'm going to look into get one of those as well. When you're talking about comparing different devices, or clamping power from amplifiers using different devices and comparing the readings, and they're using tolerance within 5%. The tolerance of each individual component within 5%. All right, so what does that really mean? So on a worst case scenario, you have, and I'm just going to use this as an example, device number 1 and device number 2, just as an example. All right, if device number one is 5% below the tolerance, then, and device number 2 is 5% above the tolerance, then that's a 10% differential. So let's write that down. Device number 1 is minus 5%, and device number 2 is plus 5%. So if you've got a 0 reading in between, you've got 5 here, and then 5 here, then that's 5 plus 5 is 10% differential. Okay, just to make it simple. I know the negatives on the top and the positives on the bottom, but it really don't matter. You see the point. If the tolerances of each device is within 5%, because it's not really a precision device that we're dealing with. It's not rocket science. We're just clamping power out of a car audio amplifier. So if the tolerances are within 5%, then the outcome can be up to 10% off. It can be up to 10% discrepancy. Up to 10% discrepancy. So what does that look like in real life? So let's say we have a 1,000 watt amplifier. We have an amplifier that's 1,000 watts. Okay? So 1,000 watts minus 5% is 950. 950. 1,000 watts minus 5% equals 950 watts. All right, so plus 5%, 1,000 plus 5%, that is 1,050 watts. Right? So 1,050 minus 950 is a 100 watts differential. So 100 watts differential. So for every 1,000 watts that we're clamping power, then you can be off 100 watts, and it's still within the tolerance of the components inside of each device. Okay. So for every 1,000 watts, you can have up to 100 watts differential. So 2,000 watts, you can have 200 watts of differential. And for every 3,000 watts, you'll have 300 watts differential, etc., etc., etc. So keep this in mind, whatever testing that you watch online or any testing that you do personally, just keep this in mind. For every 1,000 watts that you're clamping out of an amplifier, just remember that 5% tolerance, that's 5% to the positive and 5% to the negative. That's a 10% differential. So for every 1,000 watts, each device can read up to 100 watts difference and still be within the tolerance of that device. All right, so I just wanted to point that out. That's about it for this one.